All right, hello. My name's Ben Sanderson. I work in the climate change research section in CGD. I'm going to be talking about future CO2 forcing scenarios which are significantly greater than those which are traditionally considered in the IPCC process. So over this summer there's been quite a lot of extreme weather stories which have hit the press. There was the droughts in the Midwest, there was the unprecedented short surface melting events in Greenland, and there was and right now, there's an all-time minimum in sea ice extent in the Arctic. And these have provoked a lot of discussions about whether these events can be attributed to climate change. This is a very difficult problem. The IPCC is rather cautious when addressing detection attribution of individual events, and yet that doesn't stop the public in general from now being perhaps more aware of climate change impacts than they were in the past. This doesn't necessarily translate into political action. But ironically, over the last 4 years, the emissions, or the net emissions from the United States, has actually decreased, such that today we are the US emissions are down to 1990 levels. This is nothing to do with politics. This is to do with the fact that the power stations, to a large degree, have shifted towards the use of natural gas from fracking rather than coal. This situation is not repeated throughout the globe. Increasing emissions from the Far East means that global emissions are increasing by about 1 trillion tons every year. And that means when we compare it to the emission scenarios which we consider in the IPCC process, emissions are rising faster than any of the scenarios we've currently considered in the process. In the new version of the IPCC scenarios available, with the range of emission scenarios has been extended such that the lower end emission scenario we have has concentrations going down toward the end of the century. This is a rather difficult thing to achieve because that, by 2070 onwards, involves actually pulling CO2 as a planet, as a population, out of the atmosphere. This is a technology which we simply are unable to do at the moment. This requires things to be invented. When we consider the high end of the situation, of the scenarios we have, things don't look quite so implausible. Yes, it's a fossil fuel-based scenario, but it still involves moderate increases of renewables and nuclear by the end of the century. What we wanted to do is to create a scenario which is equally unlikely on the high side. So we said that all future energy use would be taken from coal, and we assume the global population, rather than the traditional high development scenarios which say that global population will decline towards the end of the century, we say that we take a moderate UN projection of global population, a middle-of-the-road projection, saying that there will be 10 billion people by 2100. This makes a massive difference to the global emissions which we have by 2100. How plausible is this? Well, the black line shows how much coal we have right now. The red line shows how much this hypothetical scenario would require. We would need to discover more coal by 2100. However, the emissions associated with such a scenario lead to about 3 times more than the worst case scenario, A1FI, which is considered in the current IPCC process. That leads to CO2 concentrations which are about twice that of A1FI by 2100. This leads to a lot of extra climate change. The global mean temperatures in our all-coal scenario increase by about twice what we get in the all-coal scenario. So the red line is the all-coal scenario, the green line is A1FI. We have a global mean temperature increase of about 4 degrees C. That corresponds to a lot of additional climate change. The red line again is the all-coal scenario. This is net Arctic sea ice area in September. It completely disappears about 30 years earlier than we got in the all-coal scenario. So, yes, we could potentially get a lot of extra climate change if we burn all the coal as fast as we can. The patterns of change which we get are similar, they're just more extreme. And so this shows the pattern of surface temperature change. The same regions warm. We get some non-linear effects in the Arctic. The warming which you get in the Arctic is amplified because of feedbacks which happen at high latitudes. Same goes for precipitation. Same kind of changes, they're just more extreme in the same places. So, to round up, Few studies have considered an equal level of plausibility on the high end as the low end, and it would get a lot worse if you did.